Hello, I'm Kay Strang. You can check me out on my website, quantumid.science, where you can find more detailed analysis and material on my series of 6 podcasts, Hunting the Identity of the Quantum. The previous podcast criticized Bohr's particle model of the atom and its artificial features such as quantum jumps and spins. It is a case of mistaking the map for the territory, an expression used by Alfred North Whitehead. Schrödinger's account is much more plausible, but he was sidelined as being old and reactionary and just didn't get the cool, brave new world of quantum discontinuity. His criticism of the Copenhagen interpretation, in the form of the absurdity of a dead and alive cat, was hijacked and used to support the theory he had criticized. And this topic is covered in my next podcast. A similar approach was adopted in dealing with Einstein's criticism of the Copenhagen interpretation, detailed in a 1935 paper he co-authored with Podolsky and Rosen and is commonly referred to as the EPR paper. His criticism somehow morphed into a theory of entangled particles that could communicate faster than the speed of light, and this was used to support the Copenhagen interpretation of a world that radically diverged from the principles of classical physics. So let's take a look at these magic particles that defied the laws of classical physics. The thought experiment in the EPR paper, designed to demonstrate the contradictions and incompleteness in the Copenhagen interpretation, was hijacked. This is a recurring theme in these podcasts, and used to demonstrate that spooky action at a distance was a real thing. The thought experiment demonstrated how knowledge of the position and momentum of one particle could, by using conservation laws, determine the position and momentum of a related particle. This highlighted the internal contradiction in the Copenhagen interpretation, which claimed firstly that the wave equation was a complete description of a system, such as an atom, and secondly, the uncertainty principle, which stated that the description of the system was necessarily incomplete. This criticism should really have been the coup de grace for the Copenhagen interpretation, but somehow the criticism morphed into a different thought experiment, restated in terms of the spin of particles, whereby a prediction could be made about the direction of spin of one particle from the earlier identification of the direction of spin of the related particle. This seemed to contradict special relativity, in that information between the two particles was travelling faster than the speed of light, and so could not possibly be true. Einstein, Podolsky and Rosen thought the most reasonable explanation was that the second particle had definite values ever since it split up from the first particle. This has been viewed as a hidden variable. In a 1964 paper entitled On the EPR Paradox, John Bell devised a test, the Bell inequality, whereby 3 particles, A, B and C, have 2 possible states, 0 and 1. There are 8 possible combinations and 2 correlations. From this, Bell derived an expression for the probability of certain combinations, and for a hidden variable theory to be correct, it must conform to this. If it is violated, then quantum mechanics is correct, or rather the Copenhagen version of quantum mechanics is correct. There was a rush to prove this experimentally, but some sleight of hand was employed to replace particles and spin with polarized photons and orientation. As noted in earlier podcasts, a photon is an artificial entity produced mathematically by digitizing a wave. This means that the scientists conducting the experiment already know everything they are purporting to discover, namely 1, the wavelength of the electromagnetic radiation being used, 2, the speed of light is known, and 3, the axis along which the measurements are taken is known, so the orientation will also be known. So it is difficult to see how this experiment supports the uncertainty principle or Bell's inequalities or demonstrates entanglement or spooky action at a distance. It seems, on the contrary, to support local realism, as everything is known at the outset and corresponds to something local and physical. Notwithstanding these oddities, the Nobel Prize for Physics in 2022 was awarded to Alan Aspect, John Clauser and Anton Zeilinger for conclusive experiments on Bell's inequalities using many polarized photons. What conclusions can be drawn from this? There is a logical flaw in the discussions and experiments alleged to demonstrate the impossibility of a hidden variable or local realism account of the phenomena. Bell's inequality is based on separate, distinct classical mechanical entities and the probabilities of correlations arising from them, whereas the experiments are conducted using waves, i.e. continuous electromagnetic phenomena. The better interpretation is to accept at the outset that if a phenomena such as entanglement actually exists, then entangled means that both particles or photons are points on the same wave, and so their positions will always complement each other. There is no need for hidden variables, just an accurate assessment of the structure of the actual physical phenomena, rather than ersatz mathematical representations. Once that has been agreed, there is no violation of the inequality. Bell conceded that notwithstanding the inequalities, Einstein could still be correct if the universe was superdeterministic. He doubted this, but changed his views on everything dramatically in a 1966 paper on the problem of hidden variables in quantum mechanics. This paper is sometimes lost in historical accounts. Using Occam's razor, the particle is unnecessary ontologically and really represents a part of a wave at the Planck scale. Einstein's idea of predetermined asymmetry, as for example a pair of gloves, is still valid, especially if there are only two variables. If the particles, being first entangled then propelled in opposite directions, are thought of as fractions of a wave, and a fictional particle is located at the peak and another at the trough, then provided the wavelength and frequency remain the same, then the two particles, in inverted commas, will always have opposite values. Similarly, if I find a left-hand glove of a pair I recently purchased, I know that the next one I find will be the right-hand glove, and vice versa. It does not entail information transfer faster than the speed of light, nor that the universe is random or subject to chance, nor that there are hidden variables, nor does it support the hypothesis that prior to my finding the right-handed glove, that the lost glove is in a superposition of states. It does underscore my knowledge about the asymmetrical nature of pairs of gloves. If you want to find out more, please visit my website at quantumid.science, where you will find more in-depth downloadable essays, book lists, and original papers by some 19th and 20th century physicists. The next and final podcast in this series is titled The Quantum Cat Meets the Quantum Computer. Both are fictional. I hope you can join me again in tracking down the true identity of the quantum.